Alright, we're going to jump into 1.2 simplifying radicals. Just going to do a quick follow-up video on this because I had got some questions about it. I have got the different kind of radicals that you're going to see written at the top here, so if you need to, you can go ahead and pause the video and write these down. The first one is the square root, which is something that you're familiar with, you've seen before. Then we have the cube root, which has a little 3 on the outside, and then we would have the fourth root here, which has a little 4 on the outside, and we could keep going and going and going. And now something I want to point out here is that this square root has always had a little imaginary 2 on the outside of it. It's a little tiny 2, but we usually just don't write it. It's kind of like an implied thing. Like if you have an exponent that's a 1, you don't have to put the 1. That's the same idea here. And so now when we have a square root, we'll be looking for groups of 2. And when we have a cube root, we'll be looking for groups of 3. And when we have a fourth root, we'll be looking for groups of 4, and so on and so on. And so we'll look at what that means in a second. Jumping down to example 1a, I want to start with one that you're familiar with. We've got the square root of 9. And I know a lot of you know what the square root of 9 is, but I want to show you how this works when we try to reduce or simplify these radicals here. So what we're going to do is we're going to break this up into a prime factor tree. So that's 2 numbers that will multiply together to give me 9, and we know that that's going to be 3 times 3. And remember what we're trying to do here. For square roots, we wrote at the top that we're looking for groups of 2. And so in this case, we've got a group, we've got a pair here. Okay. And whenever you get a pair, I always say they get married and then they move outside of the radical home. So this, we'll think of this as kind of like the house here. So when you get a pair, they get married and they move out. And then there's nothing left in there. There's no other numbers that are left over. So this answer is just 3. Notice when I got my pair here, I didn't write 3 twice because we just got a 1 pair of 3's. So I just put 3 one time. Let's take a look at one that's a little bit more difficult. So now we're looking for the square root of 54. Again, remember, there's this imaginary 2 here telling us that we're looking for pairs or two of a kind here. So I can start to break this down a couple different ways. I'm going to go with 2 times 27. If you go a different route, that's fine. You'll end up with the same answer here. And then I'm going to keep going here. I'm going to do 3 times 9. And then I'm going to do 3 times 3. And for this one, we can see if we have any pairs. You can see that we've got some 3's here, right? So we can make a pair from those. And it doesn't matter which ones I circle, but I'm only allowed to circle 2 of them because that's the number that was on the outside here, telling me I'm looking for pairs. Okay, so those 3's that I just circled, they're going to get married and move outside the radical. But for this one, we have some leftover pieces. We have this 2 that's left over, right? It didn't get circled, so that's got to stay living at home. And we've got this 3 left over that didn't get circled, so that's got to stay living at home. So they don't get to move outside the radical because they didn't have partners, they didn't have pairs to move out with. There are some other numbers here. 9. Notice I don't care about the 9 anymore because I broke it into 3 and 3. And 27, I don't care about that because I broke it into 3 and 9. So I don't have to worry about those numbers because they've already been broken down. It's just the ones that are hanging at the bottom here. And then we can finish this up by saying, okay, we have the 3, that's a big 3, right, times the square root of 6. And I'll keep going here to letter C. For this one, this is a cube root. Notice it has a little miniature 3 on the outside. That's telling us that we've got to get 3 of a kind here for them to get married and move out. So I'll start to break this thing down. 16 we can do a couple different ways. I can go with 4 and 4. And then keep going 2 times 2 and 2 times 2. And remember, I'm looking for 3 of a kind here, so I can circle up 3 of these. So I've got one group of 2's here. They get married and they move out. And then I've got one leftover 2. So this leftover that didn't have any partners, it's got to move back inside the radical. And then remember, there was a little 3 to start outside the radical, so I got to keep that there because it's a cube root. And so my final answer would be 2 times the cube root of 2. And we'll keep going here to letter D. Now we've got this fourth root here, right? So it's a little miniature 4 on the outside telling me that I need 4 of a kind to get a group that's going to move out. 90, big number here. We can go a couple different ways. I'm going to go with 9 times 10. And then I'm going to go with 3 times 3 and 2 times 5. And I'm looking for 4 of a kind here. If I don't have 4 of a kind, right, then that means that nothing can move out of here. So then this one can't be reduced, so we'll just leave it as the fourth root of 90. Keep going to letter E here. Okay, notice this one has a big 2, so this is like a giant 2, the regular number 2 on the outside, times the square root of 18. And remember, this one has a little miniature 2 there telling us that we're looking for pairs. So basically how this works is anything that moves out, we're going to multiply it by 2. So here we go. We'll break down this 18. We're looking for pairs because there's this 2 on the outside. So I'm going to do 9 times 2. And then I'm going to do 3 times 3. Okay, now you can ask yourself, do we have any pairs here? Do we have anything that's 2 of a kind? And you can see we've got these 3, so they're going to get married and move out. But remember, there's already this giant 2 out here. So I have that big 2, and then these 3s are getting married and move out. And then the leftover piece that we have is 2. And so we had the 2 to start. We had the 3s that got married and moved out, which gives me a total of 6 on the outside. And then this loner 2 that didn't get to move out, still on the inside of the house. And we can do the same thing with variables here. So we have the little miniature 3 here, telling me that I'm looking for 3 of a kind here. And we've got x to the 7th on the inside. Remember, x to the 7th, well, that's basically like the same thing as x times x times x times x times x times x times x. 7 times, right? Because it's x to the 7th. So I'm looking for groups of 3 of a kind. So I get 1 and I get 2. So those x's are going to move out. 1 group, 2 groups. And then we have a leftover x that didn't have any partners. So this was our first group. This was our second group, right? And so then x times x on the outside is x squared. And then we have the cube root of x. And then we'll go to the last one, letter G here, kind of putting it all together. This is a big 3 on the outside, so I'm going to rewrite this so you can see a little bit clearer. That's a big 3, and then we have the square root of 8, x to the 6th, y to the 9th. Okay, so remember, if there's no number on the outside, that's an implied 2, so we're looking for pairs here. I'm going to start by breaking down the 8. That's going to be 4 times 2. And then 2 times 2. And remember, we're looking for pairs, so I can circle up 2 of these here. They're going to get married and move out. There's already a 3 out there. These 2 is getting married and moving out, so they're going to come out and join it. And then I know I'm still going to have this 2 that didn't get paired off inside the radical. Now let's look at the x's. This is x to the 6th. I'm going to move over here. 1, 2, 3, 4, 5, and 6. Okay, so I need pairs. That's 1, 2, 3 pairs. So that's going to turn into x to the 3rd because there was 3 pairs. And then the y's is y to the 9th. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's 1, 2, 3, 4 pairs of y's, and we do have 1 leftover y. That's got to go back in the radical. So then my final answer would be 3 times 2, which is 6, x to the 3rd, y to the 4th, times the square root of 2y. Alright, hopefully that helps you out a little bit with the other videos. You can kind of put it all together, and if not, I'll be available on Thursday morning for office hours. Alright, thanks.